Okay, guys, welcome back to our final live session for today. I'm sure you're itching. Okay, I know you're itching because I've been putting off this announcement for so long. Before we get into our robotics class for today, which I know many of you guys have missed, I have an announcement. I'm going to say it now, so just get ready. The announcement, the special announcement I have been putting off is we are having a scratch competition. Yes, guys. It is called African Code Challenge. And what the competition is about is we want young students like you to design the future of education and learning by creating a scratch project focused on how you envision the future of learning and also create a 2-minute video to explain how your project works. So it's going to be based on Scratch. It's from people between the ages 8 to 16, which is almost everybody listening right now. So if you want to join, please look out for it. Registration and submissions start on the 1st of September and will be over on the 31st of September. You can join individually or you can join as a team. So you can start thinking about who you want to be on your team. Think about how you envision learning post-COVID, how you envision the future of learning, and how you can use Scratch to depict that. Also, the top 3 teams in Nigeria will advance to a continental final for Africa. And then the top 3 teams in Africa will be selected. There will be prizes. Definitely, there will be prizes. Expect more information to be posted on forum.coderina.net. So please look out for that. I can't wait for you guys to compete. I can't wait to see who the winner is. And I definitely hope the winner comes from someone who's been in our Code Arena sessions because you guys are awesome. Okay, without further ado, it is time for our first robotics class of our second cohort. So I remember in our first cohort, we had so many classes, and I'm bringing up everyone's favorite instructor. And I'm not trying to make him feel extra special, which he is, but I know you guys have missed Mr. Kenneth so much because when we were having our last session and Coderina was like, oh, Kenneth is back. I saw someone say, oh, I'm so excited. So we're all excited to have you back. He was gone for a little bit because he did lose his uncle. So if you can show him some love in the comment section, this is our way of showing you love and support. Thank you for being back. We miss you so much. And we can't
Thank
wait to
you.
learn a lot more about robotics, virtual robotics simulation to be exact. So do your thing. I mean, you're the robotics expert here. Thank you so much, Kenneth.
Thank you. So, hi guys, welcome back. I've missed you guys. Maybe you didn't miss me, but so this week, I don't know if Harris or if they're gonna screen share. So this week we have something special. Where due to the COVID situation, we've had to make a lot of alternatives, especially with the first season. So a lot of you guys might be really excited to get back into FL or like other different types of robotics competitions, but um, we can't. So we can't get together. So right now, what we're going to introduce to you is simulations. How do you guys can use different resources to think of different ways you guys can work together and still do and still get involved with STEM. So Harris, wait, who's screen sharing?
Aiden.
Okay, Aiden.
Yeah.
Click. Yeah, screen share. Okay, so in this week's topic, so this week's topic is Lego digital design. We're gonna focus more on the CAD. So if you guys remember, we did a lot of on-shape workshops previously. So we're gonna focus a lot more on those. But now we're gonna do a workshop for CAD for Lego. So it's gonna be really cool. You guys can see how that works. And then we're next week or the next session, which is I think 2 weeks from now. Go on the next slide, please. No, back one. Sorry, back. Okay, so if you guys can see, next week we'll actually have electrical engineering by Ishan. So Ishan's going to teach you more about that. And then the week after, we're going to come back to this and we're going to do virtual robotics, the simulator. So we're going to get involved with that. So today so there's 2 parts in with the simulator. It's first you have to CAD your robot. So you have to make your robot. And then you have to actually get involved with the simulator. Yep. So and then the week after, we're going to get you involved with and the engineering notebook. So the engineering notebook is really important for like FL, FTC, and a FRC too, and also when you advance into your future engineering career. So, Illuminati, FTC Illuminati, they'll really teach you and tell you about how to write an effective engineering notebook. And then to wrap things off for now, I'll do an aerospace engineering plus aerospace career and mechanical engineering career workshop. So I'll tell you how planes fly, how all that stuff works. Yep. So I hope you guys enjoyed these topics. So now let me introduce you to a great, really good and talented group of students. FTC team 14531, the Second Rebellion.
Hello, we're the Second Rebellion. Thank you, Ken, for introducing us. My name's Harris. On our team, we also have Aiden and Tyler. We're from the Second Rebellion, team 14531. We're located pretty close to Walnut Valley Robotics, located in Walnut, California. And we're just going to show you how to go over the basics of the LEGO Digital CAD software, or we'll abbreviate it many times to LDC. And we'll also show how you get it paired with the Virtual Robotics Toolkit software. Okay. Next slide. Yeah. So I'll start off by doing a team introduction about FTC in general, mostly. So we participate in a robotics competition called First Tech Challenge, and we play on a 12 by 12 by 12 feet field. Our team builds robots 18 by 18 by 18 inch with a weight approximately 45 pounds. During the normal season, there's usually around 2 to 3 months between the kickoff or the start of our season, where all the game material is released, and then to the first tournament. And then our season will use a variety of custom and commercial off-the-shelf parts in order to build the robot. Some custom parts we may use include a CNC and 3D printer, or maybe laser cutter or water jet. Okay. Our programming language used is Java, in which we use Android Studio to successfully communicate between the robot and our driver controller. Okay, and then in the bottom left area, you can see an example of an FTC field during one of our competitions to show size for scale. In the bottom middle, there's an example of where we are in the first tier, which is the middle. In the right, we have an example of our 2019-2020 robot, and in the middle is just an example of the UI of Android Studio. Okay, next slide, please. So this is our engineering notebook. As Ken briefly mentioned, there will be another workshop about it. I'm just right now just wanting to mention how we use the engineering design process to successfully build a robot. So in First Tech Challenge, we do need to submit an engineering notebook, which is very similar to First LEGO League's engineering notebook. Starting from the top left side, there are just sketches of our possible robot designs, in which we need to start brainstorming ways to manipulate the objects. We're going to start using different methods to keep the best ideas, and then start on the CAD. Lastly, you see images of competition bots with their descriptions in it. This is just to show how we have to describe how and why we have to build our robot this way. Okay, next slide. Thank you. So this is going to be the table of contents we're going to have for today. For today, we have to first introduce the softwares we're going to use, and then the methods to download and run the software. In this presentation, as Ken mentioned, there's going to be more focus on the LDC software and not on the Virtual Robotics Toolkit, but we'll be focusing on the Virtual Robotics Toolkit next time. Okay, and then we'll also show an example of a format for a basic FLL bot with the link provided if you want to build it in CAD. And then lastly, we'll show a sample of how Virtual Robotics Toolkit links, but then we'll go in depth to the next week as there are a lot of questions and there's a lot of intricacies inside Virtual Robotics Toolkit. And then we'll be looking into chat for any questions. Okay, next slide. Okay, so this is just a description of what software we're going to use today. I'm going to give a brief description of which one is which because it does get confusing after a little while because like LDRAW and LDC, they do mix up, and LDD. Okay, so from first on the list, we have Virtual Robotics Toolkit. It's a simulation program for a LEGO robot. Some features that you can use with the Virtual Robotics Toolkit include the ability to pair up the motors with the software and then testing the program directly inside the software. Okay, and also make sure your computer-aided design model actually functions like an FLL robot and properly works. Also, there's the ability to test out different environments with the software, such as this year's field, or maybe you built a robot for last year's field, you can still test it. With the software, there should have been a license distributed. In the images, you can see that the right middle one is actually an image of what the UI looks like. It's also paired with the EV3 Mindstorm software, and that's how you would usually use when you're programming. So, and then next on the list is LDraw, which is a database-like software. That is where we grab all our parts for the next item, Lego Digital CAD. LDraw is open source, and all of the parts you need for FLL is in the database, and you can even change the color, transparency of the objects. Okay. The software The next item is actually LDC, or Lego Digital CAD. It's basically a computer-aided design software for FLL. The software navigation is super similar to other well-known softwares, such as Onshape, and then maybe SolidWorks. But the part selection, or you can't make custom fabricated parts, as you can't do that in FLL either. Okay, so in the image, you can see on the bottom right, that's an image of the LDC UI, right, user interface. And in the bottom left of that image, you can see where all the parts are, and there's like 5 different Lego pieces. That's where all of the parts that we're gonna grab from LDraw are. Okay. Last on the list is the EV3 Mindstorm software. We're not going to go in depth about it. I'm just covering here to show how we still need to use it. The EV3 Mindstorm software isn't adapted at all, so that it's pretty similar to if you were to using it on an actual FLL robot. And it should look very similar, or just the same. Okay. So for this slide, our question is, how does each software we're going to use fit in? On the diagram on the left, you can see how the Mindstorm's EV3 software just communicates directly with the Virtual Robotics Toolkit. In the Virtual Robotics Toolkit software, there will be basically no latency between updating from Mindstorms and then the Virtual Robotics Toolkit. They're connected at the same time. On the other hand, if you can see on the right side, there's the Lego Digital CAD software, which is connected to LDraw. Those are actually connected just via software, but then to connect it to the Virtual Robotics Toolkit software, we do need to download an LDC file, and then we have to import it into the Virtual Robotics Toolkit. This is just so that there won't be any instantaneous update. Let's say if you update the CAD and then you update the Virtual Robotics Toolkit, unless you maybe save. Okay, next slide. This is So this is a pretty important question of how can you incorporate this to FLL, sorry. One possible strategy we can actually use is just like the engineering design process. We can first CAD the robot, and then once it CADs, and once you think it looks fine, or the prototype stage, then you can start building the physical iteration. After you build the physical iteration, there might still be a little few tweaks you may want to make. You can first make it in the CAD, and then just make sure it still works in the physical design. And then you can start on the Virtual Robotics Toolkit programming. And then inside the programming, once you get it to work in the virtual environment, if you want to go physical, you can. Okay, Aiden?
Okay, so now I'm going to start off with actually showing how to download some of the software. So first we have to download LDCAD, which is this link here. I will, oh wait, no. Okay, I will copy it into the chat. And then you guys should be able to view it from there. Okay, wait, can someone else copy it? I'm not.
I'll do it. I'll do all the copy and pasting.
Okay. All right. So you need to click that link, and then it should bring you to this page. And you're gonna need to So you need to click Setup, and that's right here. And then at the bottom left, your download's going to start. You click Keep, and then this one's a pretty short download. So then you just click this once it's done. And here it's going to go black because the recording software doesn't get this part, but you just click Yes here. It's going to ask if you want to allow the app to make changes to your device. And that's it. Next, we are doing the Virtual Robotics Toolkit, which is, the link should be the, okay, I'm going to put all of the links at one time so we're not interrupted. So just like remember the order and remember which link that you already clicked on, so then we can just, so that we can do it without being interrupted. Okay, so, and you should be able to tell by the links which one it is. Like for, this is the Virtual Robotics Toolkit link, and you can see in the link, you know, it's Virtual Robotics Toolkit. So the same thing will start happening, and it will start to download, and then just click on it. This is also a pretty short download. The two longest downloads are LDRAW and the EV3 program. So you click Agree, and then just click Yes here again. And the download will begin, and that's it for that one. Now for EV3, you're going to want to click on the education.lego download. So you click download and click the download in the bottom left. And this is actually one of the softwares that's going to take a little while to download. So just click yes again here, and then it's going to extract. So we're just going to skip ahead to when it's almost done. Then you click next here, and make sure you go to student edition here. And that's it for the EV3. And for LDRAW, you need to click the last link. And it will bring you to this page. It's not loading. Okay, so for LDRAW, it'll bring you to this page, and you need to click where it is. So I'm going to click here. And there should be a download button, if I remember correctly. Yeah, okay, so as you can see, you're going to click this download button, and it will start to download. And then so the same thing is going to happen. It's going to go into the bottom left, and you just click on it, and you're going to have to allow it to make changes to your device. So you click yes, and that's pretty much it. So once you guys have the softwares downloaded, you're going to need to link your LDRAW parts library to the Lego Digital CAD software. So what this is doing is basically, you need to do this so that you can actually use all of the parts that you just created. Because if you don't do this, then your parts will be very limited. But LDRAW makes it so that you can use whatever parts you want. So there's really no limitations. once you get into LDC, you'll see a similar screen to this. You go to up here, you click Preferences, LDraw, Search Library Paths, and you can see I already have it created here, but for you it's not going to be there. So you click New, and then click on the one that you've just created, and then Browse Folder, and then I have my LDraw download folder. Probably should be in the same area. It's in local disk, and then you click on the entire LDraw folder, and you select the folder, and that's it. So this is basically our LC layout or GUI. So you can left side, top of the left colors, and we'll go over a little bit more. And below you can see library, which is into different. Easily go through each and it's organized for you. On the right side, the big box is we actually are.
Aiden, I'm gonna have Harris share the screen. So so Victory, can you actually change it to Harris, the screen? Hello.
Slide. And over. Do you see this?
Hello, Aiden.
No, it's not loading.
Wait, Harris, can you hear my voice?
Yeah, we can hear
Yeah,
you
I
just
am
fine.
ready to screen share.
Okay.
Yeah,
Okay.
I'm
I
ready
think
to
your
screen
screen
share.
is on there right now.
Okay.
I think it's.
Aiden, can you go back
I think
to?
Aiden's frozen.
Yeah.
Does he? Is he?
Okay, so I'm just gonna. Aiden.
Yeah,
can you hear?
Aiden, you're lagging really bad.
I think Aiden's frozen. So okay.
Okay, yeah, I'm gonna give the rest of the presentation. So you can see how right now we have on our screen the color wheel, the part library, and the main view. So in the main view, which is the general area where everything is, right? This is basically the same thing as other CAD software, such as Onshape, where you have to navigate and then you can just right click and move around, right? And then on the left side, we have the part library, as mentioned before. This is where all the parts we're gonna import from the LDraw software. That's where all the parts are going to be. Color wheel, right now you actually can't see the color wheel, but this is on the top left of the screen. That little area is where the color wheel is going to be. Is my screen fine?
Harris, or I don't know if Aiden's back. Can you? Some people are asking if you could explain the last slide. So if you can go back.
Is the last slide
yeah.
a little?
I think
Yeah.
Wait,
Aiden's
can you
back.
guys hear me?
Yeah, you're good now.
Okay. Yeah.
I think
So
when I was screen
oh,
sharing,
do you
it
wanna
was like
you wanna start
handy.
over from? Yeah.
Okay.
Yeah, you
Okay,
start over from
so
not. I don't think you can do the. I don't think you need to do the download stuff because the download stuff is easy. So
Okay.
yeah.
yeah.
Yeah. Okay. Yeah. So yeah, Harris screen share, and then if Aiden cuts out, maybe Tyler or Harris goes in and talks. So yeah.
Okay.
Sorry about
So
that,
you
everyone.
just wait, go back to the beginning, yeah. So basically, to link LDRAW to your CAD software, go to Preferences, click LDRAW, click Search Library Paths, and I already have one created here, but for you, that's not going to be there. You only have two things here. So you click New, and then click the one you just created, and then click Browse Folder. And this is probably where a lot of you got confused. Here's pause it. So if I'm not sure about Mac, but if you have a Windows computer, then it will probably have downloaded in your system drive. So as you can see, in your local disk. So that'll be on the left side, and you just click local disk, and then click Program Files 86, and then just look for LDRAW, and it should be there, unless you chose a specific download, which you probably didn't. Okay, so so as you guys can see on the top left is our color wheel, and Harris briefly went over that. So we'll go more in depth for the color wheel later. And below it we have our parts library, and each part is like located in a specific folder. So it's very organized for you instead of like in real life where you would have to organize all of your parts. It's just organized for you. And to the right of that, we have our main view, which is just all the parts where you're going to be building everything, where everything's being put together. And yeah. Okay, so to start a new project, click on Start New Model, and then at the top it says Name. You can name it whatever you want, it doesn't matter. And then you can also add a description, but we didn't for that one. And as you can see, we have this graph thing at the bottom. And if you right click and hold and drag, then you'll be able to move around your piece and basically view around it. I choose different viewing angles. So as you can see, we have our piece here, and we're able to move around it. And this is just by right clicking and dragging. And also another cool feature is you can, in the bottom left, you can choose this, and if you choose the one at the top, then it will, instead of moving around it, it will just move like up and down. Next slide. Okay, so as you guys saw earlier, we are able to change the method of how we use the pieces. So as you can see, this is the grid method. This is what it'll default to. So once you download the software, it'll just automatically go to this. As you can see, our pieces are automatically, they're not snapping together, but, well, they are automatically snapping together, but it's different than another feature called part snapping. So this is basically like each piece is on a grid, and there's only a few specific places they can actually go. So that's how they're able to snap together so easily. And now this is part snapping, which if you go to the bottom left, we go through our parts first, and we take out a piece. And then we go to the bottom left. You can see here that it says these two options here are really important. So if it says enable, disable the auto editing plane. So what that means is, like, if you disable this, then you'll be able to move your piece freely without the grid. And the part snapping will make it so that once you go near a part, the piece will automatically link to it like a magnet. So as you can see, I'm able to move my piece freely. And if you turn off part snapping, then it will not go to the other piece. So probably use either the grid method or part snapping to easily put your pieces together. Okay, so as you can see, we have our parts library here. And if we drag out a piece, So you have all of your different libraries here, but you might be wondering, where do I get to the FLL parts? That's on this gear. So you go through here and you click on this gear right here. And that will bring you to, or no, you scroll down and you click on the EV3 brick. And it will bring you to this. So then you're able to drag out your brick, and this, as you can see, there's like a wheel here, and you can use this to rotate your piece. And this is one of the key features in LDC. And we have our rectangle here. So the middle one is able to be, you can move the piece up and down, left and right. And the bottom one in this little rectangle moves the plane. So let's say you want to move your piece to a different position without changing your viewing angle of the piece. That's very useful. So next we're going to go over how to use submodels. And if you don't know what submodels are, or you haven't had experience with them, like in Onshape, Fusion 360, Inventor, or SolidWorks, which are other CAD softwares, you're able to create these things called submodels. Now, LDC is different because it automatically groups the submodel as one part. Unlike other CAD softwares, submodels don't automatically update in a model. So we're gonna go over, so basically what submodels are is, let's say you have your drivetrain, which is like your motors and your wheels, and then at the top you want to have your brick and maybe some like an arm or something. So instead of building those two things, well, you build those two things and then you can actually combine them into one project instead of having to build it on the same one, which can be pretty unorganized. So next slide. So let's say you have your piece here. This is the piece that you've created. And to create a submodel, click the button at the top with the house and the plus. You can name a submodel whatever you want. It doesn't matter. And you can also name the full submodel or the full model. So the top is your submodel, and then the next one is your full model, what you're trying to create. And you might be wondering, well, where did it go? So I'm going to drag out another piece here so that we can have, so it shows it's a different project. So you click here and here, and then you'll be able to drag out the piece that we've just created. So I'm just gonna feature some of the other things that we were doing earlier, so maybe you can get a feel of how some of the controls work. And there we go. Okay, next slide. Okay, so this is our LDRAW wiring. So as you can see, you can pull out the wires from your software, and then it will automatically, so the first thing you need to do is make sure that part snapping is on. Now we showed how to do that earlier, and that will automatically make it so that your wire will snap into where it's supposed to be. And then now you might be wondering, well, the wire just moves as one complete unit, so how would I plug it in to, let's say, the motor up top? So the thing that you need to do is go to Session, and then click Interaction, and then enable nested editing. And once you do that, you'll be able to just select one of the ends of the wire, and you'll be able to move it. So it'll start, it'll flex around, and it will, you'll be able to move your robot around. And then using the wheel, you can rotate it, and it will automatically snap into place. Okay, next slide. So to save your work in LDC, it's pretty simple. All you need to do is go to the top and click. Wait, Harris, can you restart the video? I think I missed the first part. So just go to the top and click this button where you play. So go to the top, click this button up here. It's a blue button, and it'll bring up your folder. So you could just make a new folder for specifically LDC projects, or you could just put it on your desktop. It doesn't matter where you put it, but I recommend having like a specific folder for each project or each different, like just a place where you can put all of your models. So then you click that folder and then you type your name and click save. So now we're going to go over the color wheel, which we saw earlier. So we have our wheel up top, and you might be thinking, well, that's different than what we were on before, but that's just because we selected one of the things. So we selected transparent. And as you can see from the parts library below it, that we have all these different colors, and then below we have selected blue. So transparent makes it look like this. So the pieces are transparent. I kind of like this effect because, I don't know, you can see through the pieces. It looks cool, I think. So, and you might be wondering, how do we get it to not be transparent? So right now we're selected on only transparent parts. But if you want to go away from transparent, click this back arrow, and you'll see here that we're at what we were at before. So we have solid plastic, which is what's here now. It's just the solid black color. And we can basically choose any of these. And you have solid plastic, metallic. There's a bunch of different options, and I just recommend experimenting with some of these. So you can see in the parts, or you can see in the colors wheel that for solid plastic, there's a lot more options for colors. Whereas transparent, you only had about 2 pages of the wheel. With this, you have 10. So it's a lot more options to choose from. As you can see, there's the little bar under our color wheel. So what this does is you can basically hot swap between specific colors. So let's say you're swapping between black and red parts. So what you can do is click one of the boxes and choose red, and then that way you won't have to go through each of the color wheel pages and choose red and black every single time you want to switch colors. So that's just for convenience. Okay, next slide.
Tyler, it's so next up we have Tyler. He's going to be introducing from right now to the end of everything.
Okay. So now you might want to hide your pieces. So say if you're building something behind, you can play the video. Say if you have something behind your pieces and you don't want them to be there so that you can see what you're doing. So you press this little red square, and once you've pressed it, you just have to press a cube and press it again. And then that'll make it disappear. The piece isn't gone, it's still there, but you just can't see it at the moment. So this can be useful in many ways. So if you click this button, it'll revert everything back, and then you can click as many as you want, and you can just make them disappear. Again, this is useful because, say, you're trying to wire something and you can't see where you're trying to put the wire. So if you make a couple of the blocks invisible, you can see exactly where it is, and then all you have to do is press one button, and then they're all back. So there you go. And then next video. Okay, so this is the link will be in the chat or not, I guess. Someone's gonna post it. But this is the base robot that comes in every EV3 Mindstorm robot brain kit. But so when building this, it's just instructions on how to build a robot. But this is one of the examples where you would use one of those submodels if anyone was confused. Like once you finish one of the motors, like there, you would created a submodel for it so that you could come back and then copy and paste 2 of them, so you won't have to build both of them at the same time. And you don't have to build the base robot. Because there's no actual Lego pieces involved, you could build anything you want. Even things that aren't technically possible in the real world, you can build. I don't know how well it'll work, but it's just creativity's there. You're not limited by how many pieces you have or how many, or logic. So here we'll show you again in a tiny bit. There's going to be another example where you use a submodel right there. So you would probably save that as a submodel. So if you accidentally crash, the program accidentally crashed or something, you wouldn't have to redo it, and then the rest is pretty simple. Okay, so yeah, next video. Okay, so this is how you import your robot from LDC to VRT. So you're gonna go up to File, and then you're gonna press Export Model, or Control E on your keyboard. Once you've done that, you're gonna name your robot. We have it Sirius 1.2, and you're gonna change it from an LXF file to an LDR file so that VRT can actually read it. I don't know why it starts out as that file, but it just does. So once you've done that and you're happy with the name, press save. If you see this warning, it means you have something else named that. So you either want to change the name or you can replace it. So now that we're in our VRT software, you get started with EV3, and we're gonna show up on this little map. We'll show you how to do all this later in a couple next slides, and then next week. So we're gonna have a base robot there, and so once you log in, you always have a robot, but we do not want this because we import our own. So we're gonna delete character or an actor and import robot. So we could see Sirius 1.2 is the robot we just exported. So it's right here. We're gonna click it, and we're gonna import. Okay, so this is just loading. It takes a while for it to load, and it just shows every piece that's loading. And then if you see this this notification, it means that your LDRAW library isn't currently up to date. You have to either decide if you want to continue or not. Ours is on 99%, so it's probably not a big deal. But if yours is lower, like 50% or something, you're probably going to want to update it. So we're just going to ignore it. Pretend it doesn't exist. And then it'll continue to load. And then once it's done loading, you're going to press next. Okay, so now we can see our robot, all our wires, and all our components. So if you just wanted to scrub around the robot, you can do that. Can be fun. But we're going to see the components. So we're going to click component 1 main, and we can see what's green. That's what that component is. So we're going to name it chassis. So what the component does is everything that is green there will move on its own. So this one down here is the ball caster. So that means the ball caster will move independently to everything else. So it just makes it easier if something's rolling that you can control it by itself instead of it being tethered to everything else. So we're going to name this one accordingly as ball caster. And then next component is the left wheel. So that's the axle, a part of the motor, and then the left wheel. So this will move independently to everything else. And we'll name this accordingly, left wheel. And that means the other one has to be the right wheel. So you can see same parts are highlighted. It's the same construction, and we're just going to name it the same. Okay, so now you might be wondering what these cable ends do. So in LDC, the cables don't actually have any means to connect to each other in VRT. So VRT actually doesn't know what the cables are and what they do. So you're gonna have to specifically tell them where they're gonna be going. So here you could just see, you click it and then you go to this drop down and connect it to the chassis. You're probably gonna want to connect every single one to the chassis, because unless you have a motor connecting to a motor, which I guess you can do. But you can't click all of them at once. You're gonna have to do it individually, but it does save your last choice. So I guess slight bit of convenience there. Okay, once we've done that and we're happy with the naming scheme, we can press next. Okay, here you can see our color sensors, all our servos, and then our motor ports and servo ports. So we're gonna start with the color sensors and we're gonna name them. This is for simplicity when coding in the future. So you can see this is our left one, so we're gonna name it left, and the other one's gonna be right. So this is, again, when you're coding, you probably want to name your motors so you understand which one you're coding, so you don't end up having everything backwards or whatever. So we can see this is our left NXT motor, and we're going to name it accordingly. And then the next one is going to be the right NXT servo motor, and we'll name it accordingly again. The last one is an EV3 motor, and because there's only one of them, there's really no need to be naming it, so we'll just keep it the same. And then now this is where the cables matter, because we'll be putting in which port we want to go into. So this will be the EV3 port, or the EV3 motor. So this is just, again, so when you're coding, you know which motor goes into which port, so you don't, again, end up going backwards or doing whatever. So we'll put our we'll put our color sensors in, and then once we're happy with our selections, we're gonna press next. Okay, so this is where we're gonna have key combinations. So you're gonna press that if you want to have your own custom key combinations, but we'll go into how to do presets in just a second. So we're gonna have key A, and we see this drop down. We have up, on press, and on release. So you have options when you want A to register. So we're gonna have this is down. So whenever A is down, it'll complete the action. So we're gonna do 100% speed, because every time we want to click A, we want to go at 100% speed. And then we're gonna do next key. And this is where it might be a bit confusing, because we're gonna do A again, and when it's up. So this is once you release it 100%, it's not going anywhere, it's not doing anything. So it's make sure that doesn't mess up. So, but we don't need those. We're gonna delete them. This is the presets. So you see we have a left wheel preset for WASD arrow keys and a game controller. And then we have right wheel presets for the same thing. And then this is very easy, very simplistic. So we're gonna click WASD, and you can see it does everything for us. Both W's, so go forward and then stop. So it just does everything for you. Okay, so something nice about the software is that you can see here our motor is upside down, and usually you would have to tell the robot that it's upside down, but VRT software already knows that it's upside down, so it'll already do negative 100 for you, so you don't have to specify that. So once we're back into the software, and we're happy with the selection that we choose, we could, again, still add keys and whatever. We'll go to the right one, where we're going to do the same thing. We're going to add a preset. And that preset's going to be right wheel WASD. Same thing. Everything, keys the same. And then you might be wondering what these arrows do. That's for orientation. So if you built your robot and in LDC and it's backwards, you could orientate it here so that again, you're not going backwards, left to right when you meant to go forward, right, left. And then this is where the custom key combinations are really useful, because we're going to do this one as X, and it's down at 100%. So because there's no real key combination for this, we can choose any key on the keyboard that's not already being used as one that we can do. So we'll do X at 0, and then we'll add a new one and do C at 100 and 0. So again, the 0 part is to make sure that once you release 100%, your robot won't mess up. And this one will be at negative 100, so you could do the reverse of it. It's usually for an arm or something, where having forward and backwards different controls would be useful. And we're going to press next once we're happy. So our model is being loaded in. So this takes a couple minutes. So we just sped through it because it's not very interesting to watch. So once it's done, we've pressed finish. And your robot might be on the ground. Not a big problem. You just press these arrows and you drag it up. And now you have a robot that you can play around with, do anything with in this sandbox map. Okay, so this is the intro to the Virtual Robotics Toolkit. We'll get more in depth next week. This is just a starter. So we can see here, that's the file button that does that. And we're going to press the EV3 map sandbox. You could do any map, but we're just doing this one as a demonstration. So you can see we have the Mindstorm app open as well. And then we're having a split screen so that we could code and look at the simulation at the same time. So once you press the play button, you could do WSD, and these are the controls that we said earlier. And we can move the robot around, do anything. So it's now driver controlled, so it's not coded. But if you want to code it, we could do new program, and you select new program, and then it's the same thing as you would normally use for a normal robot. Everything's the same. It's the same program. You even have to press download, even though it's a software thing on a software thing. So then you have to navigate your brain, same thing, and you'll navigate to the program you want, and then you press the brain, and it does it for you. So it's exactly the same as you would have it if the robot was physically in front of you. Everything is the same. And then that's the button to reset and add more code. You have to reset it before you add more code, but that should be fine. And here we'll make it do a loop-de-loop or whatever, or spinny spin. We'll download it and we'll find the program and go. Okay, next slide, I guess. Okay, so this is, once again, we're going to go to the sandbox maps, and we're just going to show you what the buttons do. So you can see this is the file button. Our brain's still there, but we just kind of closed out of that sandbox map, so we can't get back to it. But you can see, you can do what type of simulation, or if you want just to be a first Lego League or anything. So that'll just be physics. And then once we're back into the sandbox map, we can see we have our brain and our controls. So it's right click to move around. It's left control and right click to pan. And then left alt and right click to orbit. And then it'll be scroll wheel to zoom in and out. And then the play button lets you play. The pause button stops the program, and then the reset button resets the robot. And then we have these gears. It's a settings. So say we wanted to add a color sensor and a claw or a lifter thing. We don't have to make that. It already has presets for it. So you can see we have new controls, and we have this arm that's on our robot now. So if you want to add anything, you forgot a color sensor or something, or if you want one, you could just put it in the software. This is a scoreboard for if you're trying to play a game with your friends. We'll go more into it later on. And that's a button to make the brain appear or disappear. And these buttons, all of them connect to other pieces of software that you need permission, I guess. You have to have them. So it's not overly important at the moment. Okay, next slide. Okay, so Next week we're going to go navigation in the Virtual Robotics Toolkit, and we'll go more in depth into the software that we just had. This was just a starter, so I guess we're going to do any questions now.
So thank you so much, Second Rebellion. Thank you so much for presenting this week. Thank you, Harris, Aiden. Thank you, Tyler. So I think I don't see any questions. Uh, I'll post the links more, and I think some people are having trouble downloading LDraw, so maybe we'll post another thing on how to download LDraw. So thank you so much. Remember, next week we're going to be talking about electrical engineering. So we'll tell you how to. It's a really important part of engineering, especially when you're doing circuitry, when you're doing programming and all that stuff. The week after, um, we're going back to this simulation. So I think Tyler, Harris, and Aiden are going to be teaching you more about using the simulation and how to actually interact with it. And then the week after, we'll have engineering notebooks, and then we'll wrap up the stuff with aerospace engineering. So yeah, hope you guys are will still be interested and still participate in this. Yeah, I've these last remaining topics really designed to help you in your FTC or FL career, and I'll talk about more about careers as well on our last session. So thank you so much, and I'll see you guys soon. I think we're still live.
We
Right.
are.